Hi, and welcome back to the Low-Level Devel channel's Build Your Own Linux Distribution from Scratch series. If you haven't seen the previous videos, check the description for a link to the playlist. In this video, we're going to start developing the package manager. Our package manager will handle installing packages as well as building the packages. The previous set of videos in this series we covered creating the package creator utility. So if you haven't watched those, you'll really want to check them out so you understand the package structures. So let's get started. Now we're going to start with this simple package manager that we're creating in this SPKM folder. And I've created a make file that I'm just going to kind of breeze through real quick. So it starts with the all section and it's going to build SPKM. And then C flags, we're just adding the include directory. We're creating HDEPs, which is the .h dependency files, using the wildcard in their LDOS header section. And now in our object/shared folder, we're going to get the sources from back shared.c, including the h dependencies. We're going to make the directory and build with GCC each of the object files. And then also the files directly in this folder like main.c. We're creating a section for that as well. So it's going to compile any files we put in that SPKM folder. Now we're getting the SPKM files are the wildcard star.c, and then the shared files are in the shared folder star.c. Now we're creating object files which we're linking to those shared C files is going to equal the shared object file in our obj directory. That's going to be where all our object files are. Then we're using plus equals and adding any files in the SPKM directory as well. So then for building SPKM, all its dependencies are these object files, and then we're using GCC with -o.spkm, and then the object files and libyaml and libcurl, because if you remember we're using YAML for the format. Now in our clean we're just removing the SPKM file and then the object directory. So for YAML and curl you want to make sure you have those libraries installed. Let's see, this is Ubuntu, and for this one I would use sudo apt install libyaml-dev. That would install the libyaml, which is already installed on this. And then for libcurl, I believe it's libcurl-dev, or actually, yeah, if you look, it'll be libcurl4-openssl.dev, or any of these other ones that you want to install. And if you have another package manager, just look up how to install those, and then you should be able to link to those using these -l parameters. Okay, so now going forward, if we go to the main.c, right now it's not doing anything. I'm just going to clear, see if we can build with make. There we go. You can see it built all those files, and there's the object directory which has the main.o and the shared common and package.o files, and then the binary SPKM. And we can actually run that binary. SPKM doesn't really do anything. Let me just add a printf statement up here. We'll say LLDOS simple package manager v1.0.0, just so we can see there's some actual output. Alright, let me add stdio up here. And now we make no errors, so we can just again run SPKM, and there we go. So that's what we can start with. And make clean removes those files, the build files. Okay, so now moving on, let's start by creating a method to actually load the packages. So to do that, I'm going to create a new file, just so these files don't get too big. So I'll call it package_load.c. And this is where I'm going to put the functions related to loading a package. So we're going to include our package.h, and I'm just going to paste in the rest of the headers here. So YAML.h is how we use the YAML libraries, which if you install the package on your distribution, you should have access to that YAML.h. Alright, so I'm going to start with the function LLDOS package load. So this is going to load a package, given it the root of the repository and the name of the package. So let me actually put that in our header file too. Okay. So to start with, the first thing we're going to do is grab the full path. I'm just going to use 1024 for the length of this string. I'll use snprintf full path, size of full path -1, and %s, which is going to be the root, then /repo, then / first letter and the name of the package, and then the .pck file, if you remember that. So let's see, if you let me just do find repo. So you see we have repo and then G and then glibc and then .pck. So that's, if you pass glibc as the name, it's going to grab that G for the first character and then glibc for the full name. And we did that in the other one as well. Let's see, name. So if we cat that out, you can see the YAML. Let me just cat that again real quick. Yeah, so you got name is glibc version and all the information here. We have some extras there as well. So now let's see if we can call load pck equals parse package. This is a function we're going to have to create. So we're going to parse the package from the full path. In order to parse that package, we need to use YAML. So once we've parsed it, we're going to just return the package. Alright, so let's start building that parse package function. Okay, so if I just go above here, above the package load function, see this returns an LLDOS package, say parse package, given the file name. Alright, so the first thing we want to do is actually open that file for read. So if it failed to open the package, then we'll just print out an error. Failed to open package file. And we'll return a null value. Okay, so now moving on, we're going to create two variables here, the YAML parser t, which is a parser, and YAML token t, which is a token object. So let's see, if not YAML parser initialize and give it the address of that parser. So if that fails, then we can't really do anything. So again, just print an error. Failed to initialize parser. We want to close that file since we opened it and return 0. Okay, so now we call YAML parser set input file. So we want to set the input file for the parser object to this FP. Okay. So now we'll say LLDOS package PCK equals, we want to allocate it, so we'll allocate it with malloc. Size of the package. Okay, and then we're gonna, if you want to, you can do this. If it failed to allocate, then you can say failed to allocate package, something like that. if you're concerned about you might be in an environment where you're running out of memory. It's generally a good practice to do that. So now let's just zero all this data in the LLDOS package. So now we're going to start reading the tokens using the parser. So let's actually create an enumeration here. This is going to be the state of the parser. So the state is going to start in the init state. It's going to have a key state, a value state, dep state, make dep state, extra state. I think that'll be good enough. So that's gonna associate to those. Let me just paste this up here too, so it's easier to see. So it's going to start in the init state. That's what we're going to start it in. Once it hits a key, it's going to go into the key state. And once it hits a value, it's going to go into the value state. Let's see, once it hits deps, we're going to put it in the dep state. Once it hits make deps, we'll put it in the make dep state, and extras extra. So that's how we can read the values for the right place, essentially. Okay, so we'll say parser state equals init. Char cur field, we'll say, I don't know, 255 maybe. So now in our do loop, what we're going to do is call YAML parser scan, and you're going to give it parser and token as the value, the address of those variables. So it's going to grab the next token. Now we're going to switch the token type. So if the token type is YAML key token, then we're just going to say we're setting the parser state to the key state, so that we know that we're starting to read a key. And this is similar to like a sax parser if you're familiar with XML. So now the case YAML value token, we know that where the state is value, so we're starting to read a value. And let's see, the next one is going to be, let's see, case YAML scalar token. So that's when we're actually getting an actual value. So that comes from the token.data.scalar.value. So that's just a char pointer that we can read from that. So that scalar is going to be, like for instance, this false, or this string here. So whenever it starts reading one of those, we're going to know what it is based on the state that we're in. So if the state is key, then that scalar we are reading is actually the name of a key, like name or source or extras. Let's just make this 1024. I don't know that it matters. These are all probably going to be pretty small fields anyway, but alright, so let's say cur field, size of cur field -1. Just do %s and data. So we're setting the current field to this data. Alright, and then state equals value. So if it's the value we're reading, then we're going to want to set the current field's value. So the package, we're going to pass in the package, the current field, and the actual value, that data. So we need to create this set field data function. Alright, and yeah, so this function we're going to need to create. But let's actually finish this while loop first. So do while token dot type is not YAML stream end token. So that's when we know that we've hit the end, and we can close that close FP, and we can return the package object we allocated. So we'll have to remember to free that package too, since we're allocating memory here. We'll get to that later. At this point, we're just setting things up initially. So now let's create this set field value function. So remember, we're passing in the package, the field name, and the value. So if that field name is equal to name, we're using stir comp for that, which will return 0 if they equal. So in that case, we just need to say package name equals and stir dupe the value. Those we'll have to remember to clean up as well. So let me just copy this, and we'll say, so if it's version, then we're going to set version. So actually that should be an else if. Let's change that. Alright, so I'm just going to paste some more in here. Okay, so for the other fields are going to be repo, source, and isGroup, which we're doing the same thing, except isGroup is a boolean, so we're using stircomp to check if its value equals true. And let's again look at these values. Also, we need no package too. Let's take that one. So we'll create no package. We can just copy this isGroup. Say no package. No package. So now in order to add things to the dependencies, let's see, what we're going to do is actually this function will get called when the, let's see, when the field name is deps. It's going to pass in a value. Actually, yeah, we're not going to need those dep, make dep and extra states, so we'll just get those as extra values. So really all we need is init key and value states. But for now, I'm just going to say stir list append. We're going to use the PCK deps as the list and value as the value to append. That's pretty much all there is to that. Remember, we created that in the previous videos. So make deps and extras. Yep. And that should be all the fields that we currently have. Might up ending adding more, but for now this should do. So let's see if we can test this out then. I think that should be it. And we have the package, and let's go back to main. So in our main, let's just add some code to load one of these packages. Let's see, so the directory we're in is LLD, LD Linux dist repo. Yeah, so that's where we're going to load them from. So, and then glibc would be one of the packages. Let's cat that package out again. So as you can see, it's got the name, version, and a couple of extras, so we'll print out some of the data from that. So let's also include lldos package.h. So here we're going to just kind of hard code a path in. Package load. For the root, I'm just going to put this hard code this root in for now, since this is just an initial test. And we're going to say load glibc. Alright, so we'll get the results of that. So if not package, then we know it failed. So just say you can't find package. And return -1. Otherwise, we'll print out the package. Let's say package found. We'll put name and version here. PCK name, PCK version. Let's see, what else do we want to put here? We'll put the source, because we know there's a source URL on that one. Let's see, PCK source. And I'm going to print out the extras since we know this has 2 extras, so we should be able to see both of those. And to do that, I think we're going to just use a stir list. Actually, put that in a for loop. So stir list pointer L equals the address of PCK deps, or extras actually. So while L and L stir are not null, L equals L next. Hopefully you're following that. It's a simple linked list. So now I'm just going to put a tab, colon, and then the name of the extra. Or not the name, but the value of it. And that should be it. Let's see if we can make that. Make everything built fine. Then we'll run it. And right there you see package found glibc 2.33, the source, and both of those extras are printed out. So I think that's enough for this video. I want to keep these relatively short, so this shows the process of loading one of these packages. In the next video, I think we'll start with loading them into a main list so that we can load all the packages, the database of packages, so that we can start finding them and building them and installing and all of that. So I hope you enjoyed this video and learned something from it, and if you like it, please share it, and like, comment, subscribe, and all that, and thanks for watching.